I want to talk today about some of the knobs and buttons that we have that we can use to improve the performance of large language models. One of the influential early models was GPT-2. And to give you a sense of how it worked, what it did was helped us predict that next word. This was useful if you were writing a creative story. It wasn't really useful for a lot of tasks beyond that. So while this was exciting, it didn't have that much of an impact across AI. The next improvement was instruction tuning. Instruction tuning was a fine tuning on top of those base layers. And what we did here was give it lots of examples of different types of tasks that we wanted to, and then the response that we wanted with that task. So for example, asking a question about the boiling point of nitrogen and then getting an answer. Through this process, these models started to learn and work for us for solving tasks. One way these models worked is something called zero-shot learning, where I could give it a prompt and a task, and it would then be able to immediately solve that. So for example, I could say, I want to convert from English to French. Here's the word in English. Will you give me the French word? The big improvement was with something called few-shot learning. Now with few-shot learning, what we're doing is giving the model examples. That's the few-shot. So you can see here, I've given an example of a movie review and then the sentiment I expect. And then I ask it to then give me the sentiment for another movie. And then the model then does the output. The key here is all I'm doing is inference. I'm not retraining or changing any of the model's weights. What I'm able to do is by giving the model some examples with the few-shot, I'm able to condition that and get that output. Now this few-shot learning opened us up to lots of use cases because all we had to do was explain to the model what we were looking for the prediction. This ability has been called in-context learning. And what this refers to is all these new tasks that we're able to do with this few-shot learning. Now, one of the things about this is it's often called an emergent behavior because it's something we don't see with smaller models. But as models scale up in size and they're just larger and have more of that information, they're able to better do these complex tasks. A second fine-tuning approach is known as reinforcement learning with human feedback. And this has been very important to be able to get to these models that really satisfy us and why we like the experience, for example, of chat. One way that human feedback works is that these models, after they've been instruction tuned, give us lots of great examples, lots of written ones, but they slightly differ. They might differ in terms of their tone, the style, could differ a little bit on the facts, could differ on the harms that they might have. Some might be biased. And so what we ask humans to do is then rank these outputs. We use that to train another model, and then this is used to fine-tune the model so the outputs line up a lot better with human feedback. One of the newer approaches we're seeing with this is reinforcement learning from AI feedback, where we use AI to help us determine, is this content harmful, is it biased or not? And that's been another effective way as a way to further fine-tune these models. The third method of fine-tuning is known as parameter efficient fine-tuning, or PEFT. And I'm really excited about this because when we work with these large language models, they're humongous, right? They can work across multiple GPUs. They have a lot of parameters. And if we have to train all the different parameters in those networks, that's a lot. What PEFT does is it allows us to freeze most of the weights in the model and just fine-tune a small amount. And what we found is by using this approach, we're actually able to successfully fine-tune and improve the performance of models. Now, the world is exploding with lots of different methods for doing PEFT right now. I'm expecting over time we're going to figure out what are the best methods, what are the most scalable methods, just like we've done for transfer learning for, say, images. But I think this is an exciting part of how we're going to be able to improve models so all of us can easily use them without having to use a huge amount of compute for the fine-tuning. So I want to leave you with is we have a lot of strategies for getting better predictions from different types of prompting. I've shown you few-shot prompting, but there's other prompting strategies as well. Similarly, we can also go to fine-tuning models. With fine-tuning, you're going to have a lot of different options available as well. But hopefully this gives you a starting point for thinking about working with large language models and some of the vocabulary that you see out there.